October 15th, 2016. Guys, you're looking at Cern this afternoon. Now, beam 1 is on the left, beam 2 on the right. When you see them this tightly wrapped, that means they're running at full speed. If you see the larger circles, they're ramping up, getting ready. But they've been running for the last 2 days at very high energy. This is 6-point TeV per beam, and they're colliding at 13 tera-electron volts. Notice it's proton-to-proton collisions at 2,220 bunches. The green line, guys, is the beam energy. That's what we're talking about, 13 tera-electron volts. Notice it's between 6 and 7, and that is 6.5 TeV. The red and blue lines are the individual beams. Luminosity, that's a big deal with Cern. Notice in the bottom right, you got Atlas, CMS, and LHCb. Guys, these are 4 machines that read this data upon these collisions inside this huge underground coil that reads our magnetic field, affects it, and everything else. But the green line is what's delivered in luminosity. Targeted was the red line. Notice that. And as usual, Atlas, the largest machine on the planet, and CMS have far exceeded the targeted luminosity. And luminosity is basically the amount of collisions. And remember, they're going to be moving very soon from proton to proton to proton to lead collisions. Think about that. But yesterday, on Friday, the test of what's called high pileup, and they're just putting the bunches, cramming them in one at a time, getting the highest luminosity, and that again is the amount of collisions per second, really per nanosecond. But you can see it, 2000 hours. This started yesterday, coming into 0200 hours, right at 2300, and between there is 2400 hours, and then midnight. Cern does not use UTC time. They use Swiss time. It's 2 hours ahead of UTC. Now, this morning, notice your timestamp, 10:15, just after midnight UTC. Then you add the 2 hours, and you're at 2 a.m. in the morning. But from there, and as this ramp up increased, what you're seeing in this chart in the bottom left, the middle left, is the black line is the 13 tera-electron volts. That's beam energy. The other 2 lines are beam 1 and beam 2. Notice after they got to this energy point indicated in the green line, they could let the energy taper off of the 2 beams, and it started stabilizing itself. But definitely we can see the reaction to our magnetopause. Yesterday on Paul Begley's show, Mike said that one of the reasons that Cern was doing what it's doing, and that he agreed they're definitely affecting the Earth's shields, because their magnetic field is 100,000 times stronger than the Earth's magnetic field, is that they're afraid of, during the solar minimum and whatever else is coming, that the Earth's shields are going to weaken, and they're preparing to strengthen it. Now, what are we seeing now? We're seeing the reverse in the solar wind stream coming from behind the planet instead of from the sun, because it's overwhelming that. And then we see Cern ramp up, guys. And when you see the bends and the crooked pull-ins from both the north and south pole, that is Cern. It's written all over it. It's never happened before until last year when they started ramping up. Now, this is what we started seeing, this bend, and this is where we started seeing the magnetopause reversal. Notice your timestamp, 15th. We were seeing this yesterday on the 14th. So is what's happening right now, is Cern actually trying to prevent the whatever's coming from behind the planet from affecting the shields of our planet here? I don't know. We know that there is a lot more than just that going on, but that could be one of the lines that they use for international corporation, because they're getting money from every nation on the planet, probably every college, and some high schools now are behind this plan. Notice your timestamp. Again, during the time, Cern has been cranking up actually the last 2 days, but this is today. You got from both sides You've got pressure left and right. It shouldn't be coming from behind us like that. Now, again, the possibility that Cern is trying to increase or affect the Earth's shields during these periods may be part of the reasoning behind this. I don't know. It's all new. We're trying to put it together, guys. I just wanted to mention that was brought up during the show. But look at this, pressure being pushed back up. You saw this earlier. But what I'm doing is correlating the times between what we're seeing on our magnetopoles in all three models and what's happening at Cern. Now, there's some things that you need to know. Look at this push at that time. You saw that this morning, but it correlates with, again, the ramp up and the pile up is what they're calling it now at Cern. When they start the proton to lead ion collisions, you're going to be talking about massive amounts of what's called quark-gluon plasma. That will result from extremely high luminosity, from extremely high collisions. Look, check this out. The plasma burn to the right. You saw it in the earlier video, guys. Now, we've got the sun's going into a minimum. The Earth's shields are weakening. The magnetic north of the planet is now moving about 12 miles a year, the fastest in recorded history. One of the things that could be happening as we look at all three models, and you can see the pressure coming from behind, one of the possibilities is not only does the sun do a magnetic reversal flip through the minimums and the maximums as it goes through those cycles, but the Earth can do it too. Now, it doesn't do it as often, but are we starting to see those effects? Now, not a physical flip, guys, not that, but a magnetic pole change. But it does have consequences. Look at how far these red closed magnetic field lines, which are supposed to be the largest on the other side of the sun, are bulging out. Guys, that has everything to do with the plasmasphere. Remember the video I showed you, I think it was yesterday or day before, where the plasmasphere reacts to incoming solar activity, a coronal mass ejection, solar flare, whatever, and sends that plasma out in front to protect our planet. But this time, these closed red lines, or the closed magnetic field lines, are going out backwards. Look, that's one of the largest I've ever seen. Look at the extent of that supposed closed line, and it is closed. But that, to me, is that it's throwing this plasma sphere behind the planet instead of in front of it, as we would normally see during some type of solar activity. Even as we go into the last frames on all three models, it's not straightened itself back up yet, and Cern is still running hot. Now, I had these questions. Earth's magnetic field serves to deflect most of the solar wind, whose charged particles would otherwise strip away the ozone layer that protects the Earth from harmful UV radiation. That's what happened to Mars. One stripping mechanism is for gas to be caught in bubbles of the magnetic field, which are ripped off by solar winds. Calculations of this loss of carbon dioxide from the atmosphere of Mars resulting from scavenging of ions by the solar wind indicate that the dissipation of the magnetic field of Mars caused a near total loss of its atmosphere. It's not quite total. And for years, we've been getting false images of not only Mars, guys, but some of the moons of Saturn and Jupiter. When you see the real color, you're going to be surprised in one of the videos coming up. But at present, the overall geomagnetic field is becoming weaker. That's on our planet. Think about what we're talking about. The present strong deterioration corresponds to a 10 to 15% decline over the last 150 years and has accelerated in the past several years. Geomagnetic intensity has declined almost continuously from a maximum 35% above the modern value achieved when 2,000 years ago. What else happened then, guys? You remember? Calvary. The rate of decrease in the current strength are within the normal range of variation and are shown by the record of past magnetic fields recorded in rocks. Whichever way the magma is flowing at that time during that change, and once it hardens, it records that magnetic direction. The Earth's magnetic pole is drifting from Canada towards Siberia and accelerating 10 kilometers or 62.2 miles per year at the beginning of the 20th century and up to 25 miles per year in 2003, and since then has accelerated. Think about that. Think about magnetic poles flipping on our planet. Again, not physical, but magnetic poles. But guys, that could change a lot. Did you know that the ocean is about 400 feet higher off the surface of the planet at the equator? We call it what's called equatorial bulge, and that could slosh back and forth. Anyway, this is the plasmasphere. This has to do with these red lines contained inside that closed magnetic fields that we're seeing. This was from yesterday. On the right is the sun. The plasmasphere senses an incoming solar flare or coronal mass ejection, so it expands out to the right to shield our planet. At that time, though it's decreasing in size tremendously, it is spending that energy. And when we saw it go out behind our planet today, it then dissipated because it takes time to build this up. It's a layer of slightly cooler gases. And like a living organism, it's what's called cusp in between the magnetic field lines. They can sense this incoming energy and it sends it out. But in this case, it was sending it out behind our planet. Strange days indeed, guys. We're watching it. It's a heads up. Be safe.